Hello there. Today we'll be doing search a to the matrix. This is a binary search problem number 47 of a Neetcode 150. In this problem, we are given a matrix where everything is in sorted order. We're going to use binary search to solve this problem. The first thing we can think of is to sort everything, to like attach every item into a straight line, into like one array, and that would be O of m times n time, which is already well, actually it's only, is it O of m? It should be O of m times log of m, log of n times m, which is still not the fastest. We can just do pure binary search on just the top and bottom. So to find which row it's in, and then find the item inside the row. And so that involves two binary searches. And that's all we really need to do. Okay, so it's pretty simple. So, binary search, left and right is equal to 0, and length of matrix minus 1. So we have the most topmost and leftmost less than or equal to r. So if let's get the middle item. Middle item is going to be well, left plus right. To avoid index out of bounds, we're gonna do this particular thing. It's called right minus left divided by 2. That way we don't L plus R and then we're indexed out of bounds. So that's how we do the getting the middle item. So if the matrix M of the last item, so this is the biggest item, if the biggest item is less than the target, so if our biggest item is less than the target, so let's say 7 is less than our biggest target, then we need to find a bigger target. So that must mean that we need to shift L up, the left pointer, plus equals m plus 1. Plus 1. The reason why we want to do a plus 1 is so that we can skip the current row we're on. If the matrix of m of 0, which is the smallest item, if this is bigger than the target, so if that 10 is bigger than our target of 3, that means we need to shift down a row. That means r equals middle minus 1. Else we found our particular equation and we break. An optimization we can do now is that if L, if not L is less than or equal to R, then we can return false, because that means that it is not within the matrix. So this saves us the need to do a log of the length of the row, which is let's say the number of rows is m, and the length of the row is n. So it saves us a log of n. So let's do a log of n now. So we have a selected row is equal to the matrix of m. That's our selected row that we're gonna do a binary search on. So same thing, left, right, 0. Length of matrix selected row, because we don't have to worry about anything about the matrix. Just forget about the matrix. We have the row now. So now that we have eliminated more and more information we don't need, we can perform the same operation. I think we can turn this into a get mid, probably type of function. And anyways, so selected row, we have m. If this particular is less than the target, so that basically means okay, so this is middle. Let's say it's 5, and our target is 3. Well, let's say the target is we found 7. So no, wait, sorry. So selected row middle, let's say it's 5. It's less than our target of 7. So we need to move our left pointer up so that we can get a bigger item. Else if selected row of m is greater than the target. So our current item is greater than the target, and we don't want to eliminate everything to the right of it. So right equals m minus 1. Else, we can, if it's not bigger or smaller, it must be the target. Let's return true. Otherwise, if the L and R cross, and that means we did not find anything, let's return false. And then we can return, run the code, and submit. And great, we have solved the search a 2D matrix. It's a pretty I think good problem for us to do. What we've learned today is how to do binary search and eliminating a matrix of rows, and then we did every column, or finding this correct row and doing the binary search on the correct row. I think there are multiple ways of thinking about it, and it's the idea is always elimination, process of eliminating items. So the runtime is O log m times m n, and we're using O of 1 space because we're not creating any new matrix, we're just searching, which is great. I think this is as efficient as it gets in terms of runtime. I'm sure that there's some code that people have not run that's faster according to submission, but I think this is pretty good. And so if you have any questions, comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.